I'm Anil Kumar, sharing with you a test question to review polynomial functions. The question before us is, given a polynomial function f of x of odd degree, decide whether each of the following statements is true or false. There are four statements. The first one is f of x is an odd function. B, f of x have at least one zero. C, f of x will have at least one turning point. And D is, as x approaches minus infinity, f of x approaches minus infinity, and as x approaches positive infinity, y approaches positive infinity. You can pause the video, answer the question, and then look into my suggestions. We'll try to answer these questions with the help of examples or counterexamples. We are given polynomial function of odd degree, right? That means the degree n could be, we can say 1, 3, 5, and so on. Now f of x is an odd function if you are given a polynomial with degree odd. Is it true or false? Let me sketch and then show you, and we'll also give you a few examples. An odd function really means that the function is symmetric about origin. That is what it means. Or f of minus x equals to minus of f of x. That is what odd function means. If you have a degree odd, it necessarily does not mean that function will also be an odd function. This is very important to understand, right? For example, I could have a function which is kind of like this. This is a cubic function which has been translated few units to the right. Now this function is not symmetric about the origin, correct? So this example shows that the given statement is false. The example could be f of x equal to x minus 1 whole cube. If this point is 1. Do you see that? Let's try to find what is f of minus x, just to prove that algebraically also this function is not odd function. What is f of minus x? F of minus x will be minus x minus 1 whole cube, which means I could take minus common, so we get x plus 1 whole cube. Cube of negative is negative, but inside we get x plus 1 whole cube, which is not equal to minus of f of x. Do you see that? So you can see both graphically and algebraically we can show that all odd degree functions are not odd functions. Okay, that's very important to understand. Let's move on to the next one, which is f of x will have at least one zero. Well, this statement is true, since you know odd degree functions will either move from quadrant 3 to quadrant 1. In doing so, they have to cross the x-axis, and therefore they'll have at least one zero, or they'll move from quadrant 2 to quadrant 4, right? Now, this is when the leading coefficient an is greater than 0, and this is when leading coefficient is negative. Is it okay? So therefore, this statement is always true. C, f of x will have at least one turning point. Well, as you can see from the given example, no turning points, right? To cross from quadrant 3 to quadrant 1, we don't have to turn. Therefore, this statement is false. The last statement here is regarding the end behavior. If x approaches negative infinity, y approaches negative infinity. If x approaches positive infinity, y approaches positive infinity. It is not always true. This happens only when the leading coefficient a of n is positive, is greater than 0. If we have a function which is y equals to minus x cubed, for example, that will be kind of like this, right? And as you can see here, as x approaches negative infinity, y approaches positive infinity, right? So this statement is also false. I hope that helps you to recapture the characteristics of polynomial functions with odd degree. We'll take up an example with even degree also. I'm Anil Kumar. You can like my videos, share them with your friends, and feel free to ask questions. Thank you, and all the best.